In this lesson, you will dilate a figure as well as identify the scale factor and determine if it's in enlargement or reduction. Dilation is the image produced by enlarging or reducing a figure. It is similar to the original figure. Draw the image of the figure after a dilation with center A and a scale factor of 2. If it has a center A, that just means that's the point from which it's going to get 2 times as big. Sort of think of it as if you were to stick a straw right here, it's going to expand out from that point. A is going to stay there, but all these side lengths are going to get 2 times as big. So if it has center A, that means our image is going to, A prime is going to be in the same spot. But now this line segment AD, instead of being 2 units long, it's going to be 4 units long. So D is going to be over here at D, that's going to be D prime. And then instead of going up just 2 units to get to C, since it has a scale factor of 2, that means I'm going to make that side length twice as long. So C prime is going to be right there. And then straight up from A, B was 1 unit away, so now we're going to make that 2 units away. So we're going to label B prime right there. Now let's go ahead and connect these with line segments. This new image has side lengths that are twice as long as the original. Now we're going to pretend that point A had the coordinate 0, 0. In other words, I'm going to draw in an x and y axis that goes through point A. So here's the x-axis, here's the y-axis. If I did that, we're going to go ahead and fill in the original coordinates and then the image coordinates. The original was at 0, 0 for A. A prime is also at 0, 0. B was at 0, 1. And then B prime is at 0, 2. C was at 2, 2. C was at 2, 2. And then C prime is at 4, 4. D is at 2, 0. And then D prime is at 4, 0. What do you notice when I compare the original coordinates to the image coordinates and remember that it had a scale factor of 2? You should notice that the image coordinates are just the original coordinates times 2. So that leads us to our next example. Graph triangle JKL with vertices 3, 8, 10, 6, and 8, 2. Then graph its image triangle J prime, K prime, L prime after dilation with scale factor of 1/2. So let's start by graphing the original triangle. J is at 3, 8, so we're going to go to the right 3 and up 8, and we're going to label that J. K is at 10, 6, so you're going to go to the right 10 and up 6. Label that K. And then L is at 8, 2, so to the right 8 and up 2. Let's go ahead and connect those. Ooh, I didn't want to use that. All right, then we are going to go ahead and write down the coordinates for the image triangle. J prime, K prime, and L prime, and then we'll graph those ordered pairs. It's a scale factor of 1/2, so that means we're going to take each of these ordered pairs and multiply them by 1/2. So 3 times 1/2 is 1.5. 8 times a half. Remember, multiplying by a half is the same thing as dividing by 2. So 8 divided by 2 is 4. Now for this one, half of 10 is 5. Half of 6 is 3. And then half of 8 is 4. And half of 2 is 1. So J prime is going to be at 1.5, 4, which means we're going to go 1.5 units to the right and then up 4. And we're going to label that J prime. K is going to be at 5, 3. So to the right 5 and up 3. Again, that's K prime. And then L prime is at 4, 1. When you get finished connecting these, you should have a triangle that's similar to the original, but all the side lengths should be half the size of the original. The other thing that you can do to see if you're on the right track or not is if the origin is the center of dilation. If you take and draw a line out from the origin, it should go through the corresponding vertices. So it just went through L and L prime, or L and L prime. Now we should be able to draw another one that goes through K prime and K, and another one through J prime and J. That's kind of a visual to help you see that you've done it correctly. You should be able to draw a line straight out from the origin through the corresponding vertices of each triangle. Now, if we go back to this first example, we had a scale factor of 2, and our new quadrilateral was bigger than what we started with. And then in our next example, we had a scale factor of 1/2, and our new triangle was smaller than the original. If you have a scale factor that's larger than 1, it enlarges the size. If you have a scale factor that's between 0 and 1, it's going to be a reduction or reduces the size. The last thing we're going to do is actually find the scale factor. This is probably the trickiest part. It says write a ratio of the x or y coordinate of one vertex of the dilation to the x or y value of the corresponding vertex of the original figure. Basically, just like when we talked about scale models and drawings, it's the model over the actual. The model is like the new image, and the actual is the original one or the old one. So if I want to find the scale factor, I want to compare the new to the old. the one with the little prime symbols, is the new one. So we're going to take a point such as, let's look at, how about E and E prime? Let's look at these 2 points right here. If I want to compare either the x or y values, I wouldn't want to compare the x values of these 2 points because they're exactly the same. So I'm going to compare the y values of these 2 points, and I'm going to compare the new one to the old one, or the model to the actual. So I'm going to compare the y value of this. The y value of this one is 2 compared to the y value of the original or the old figure. 1, 2, 3, 4, 5. That's going to be 5. That means the scale factor is 2/5, or this image is 2/5 the size of the original. The lengths of these sides are 2/5 the length of the original. Since it's a number between 0 and 1, that makes it a reduction. Now if I want to work on this one here, I would probably choose A as my point that I'm going to compare, because B, well, I can guess what the value is of the x coordinate here. I don't really know what it is exactly. So let's just go with A and A prime. Again, it's the new one, or this one right here. And I'm going to compare the y values because, once again, the x values are the same number in this case. So the y number for this ordered pair is 1, 2, 3. And when I compare that to the original or the old one was 1. 3 over 1 is 3. And since that is a scale factor greater than 1, it's going to be an enlargement. That means our new one is going to be 3 times the size of our old one, which makes sense by looking at the picture.